Dear students, now this is the brief explanation regarding to the paper of Mathematics 1 conducted in the afternoon session on 4th June 2022 for EEE, CSE and other allied branches. This is afternoon paper. Comparing with your forenoon paper, it is somewhat typical, but nothing to worry. I just give you brief idea, and when your answer already given in the examination center, if it is matching to our my idea, nothing to worry, maximum you will get the maximum score. So COVID pattern 8 and you are answering 5. The first A bit, apply rank test. Generally we don't have any rank test here. It is simply they are giving that some equations here it is given, asking to find out, apply the rank test to find whether the following system has any solution other than x, y, z, w equal to 0. You forget about that x, y, z, w equal to 0. The remaining equations here it is given. How many equations are there? 1, 2, 3, 4 equations. 1, 2, 3, 4. 4 equations with 4 variables. Better use that particular equations and you verify whether it is consistent or not. That is the only duty that they are going to ask you. So you are testing the consistency for the 4 equations. Deleting that first one, nothing to worry. Whether you are having 0 solution or not, that they are asking. Right. Next, 1B bit. By using Gauss elimination method, solve 3 equations with 3 variables here it is given. You can directly apply Gauss elimination method and find out the solution. That solution must match with your calculator solution. So when that is same, definitely you will get the marks. Second A bit, find the characteristic polynomial of a matrix. So obviously a 3 by 3 square matrix here it is given. You are calculating the characteristic polynomial, only characteristic polynomial. You are not calculating any eigenvalues and eigenvectors. After getting that polynomial, you are verifying Cayley-Hamilton theorem. So after verification of that, you are calculating the inverse. After getting that inverse, better you compare with your calculator, must match with your answer. Second B bit, the matrix is given. Remember that here A is nothing but it is a symmetric matrix. For that symmetric matrix, they are going to use the diagonalization process D equal to, instead of writing P inverse AP, they have given T inverse AT, nothing to worry. So a matrix is diagonalizable, it has to satisfy the condition D equal to P inverse AP. So for the given A matrix, you just calculate P matrix, which is the modal matrix. Next, diagonal matrix, then directly you are verifying whether P inverse AP is equal to D or not. If it is equal, then you call it as a diagonal, but they are not asking whether it is diagonalizable or not. A is given in terms of AHB and T matrix is given. In order to find out the theta value, we need to substitute that particular matrix in your diagonalization process. Finally you are going to get tan something you are going to get, but maximum it is somewhat complicated. Anyhow, the liberalization will be given in order to assign the marks for this particular problem. Third A bit, prove that the following series is conditional convergence. So it is conditional means alternating series is given. It is looking like summation minus 1 whole power n 1 divided by, it is some n to the power of p type they have given. So use the Leibniz test first whether it is convergent or not. Once it is convergent, then you go for conditional means you are taking the modulus for this, you just verify. Modulus is also convergent, you call it as absolute convergent, otherwise conditional convergent. In the same model they have given the second bit. So in order to get that particular value, the general term can be taken as 1, 3, 5 and so on up to 2n minus 1 divided by 2, 4, 6 and so on up to 2n. That is nothing but your general term. For this general term, you are applying again Leibniz test and verify first whether it is convergent or not. Then you go for the modulus for this. Third B bit, prove that the series is convergence absolutely. So the general term is nothing but sin nx divided by n to the power of n plus 1 type. or n to the power of sin nx divided by n cube, because cube is common in all the expressions. So directly you write down sin nx divided by n cube. So minus 1 whole power n into sin nx by n cube. For this you are just verifying whether it is convergence or not by applying the Leibniz test. It is also alternating series. Then you go for the modulus for this. Fourth a bit. Express log cos x as Taylor series. So point is given. Obviously you can go into find out the expansion for this. You start with f of x equal to logarithm of cos x and find out the different derivatives for that. Find the volume of the solid generated by revolving the ellipse. So it's a direct problem. Here it is given. Rotated about minor axis. Major axis generally said to be x-axis. Minor axis is nothing but y-axis. So about the y-axis you are calculating the volume of the solid. So direct formula is there and procedure is there. You can directly find out its answer. It's a direct problem. Then you are moving to fifth one. If u equal to one expression is given and show that this is the. So it is somewhat difficult. Obviously jntuh paper, whenever they are going to give you or conduct any particular type of examination, one question is totally different from the academics. So in the same model they have given this is also. So obviously it is somewhat typical as per my knowledge here in order to present in the examination. So nothing to worry. Definitely they are going to give you the marks for this particular problem. Partial differentiation you need to use it. Sixth a bit. Determine whether u and v are functionally dependent. That means indirectly you are calculating Jacobian for u and v. So already u and v in terms of x and y, uv are the functions and xy are the variables. You calculate the Jacobian. If Jacobian is equal to 0, you call it as dependent, not equal to 0, independent. Just you verify it. Don't calculate any type of relation. Sixth b bit. Find the greatest value of a function. So maximum and minimum value, and indirectly for that particular function one more equation is also given. Indirectly you are using Lagrange multiplier method in order to get the value. So just you apply that one, you will get the answer. Seventh bit. This is also somewhat difficult. Of course u and v here it is given. Then show that dou f by dou x. So here the problem is nothing but you need to calculate function f of x comma y written in terms of new variables. So already they have given f in terms of u and v. In terms of u and v, but they have not mentioned any type of expression for that. If that is the case, you need to calculate this one. This is also somewhat difficult and a different one also. Nothing to worry. Eighth a bit. By using techniques involving in the gamma function. So you are using the gamma function in order to calculate that particular integral. Here the integral is nothing but 0 to infinity root x into e power minus root x. Start with root x equal to t and just x equal to you will get t square. So that directly you can calculate the dx value differentiation 2t dt, and directly you substitute that one, you will get in terms of gamma function. Eighth b bit. By using the techniques involving in the beta function, find the exact value, integral 0 to pi by 4. So here it is given sin square 2x and cos square 2x. Sin square 2x, that you can write it as sin square theta can be taken as 1 minus cos 2 theta by 2. Similarly cos square can be taken as 1 plus cos 2 theta by 2. So here they are going to write down a value. Here it is. Look at your one type of relation is there in between beta function and in terms of polar coordinates. Integral 0 to pi by 2 sin to the power of m minus 1 of theta dA and cos to the power of n minus 1 of dx. By using that type of relation directly, you are going to calculate that particular simplification. But before applying that one, sin square and cos square, that you are going to write in terms of sin and cos. So using that, you are just calculating that particular integral value. Of course, comparing with your morning paper, this paper is somewhat difficult, but maximum you can attempt 5 questions here out of 8. So nothing to worry, liberal evaluation will be there, and even we are going to represent the same different types of problems here it is mentioned in the question paper, that to the university not to focus on that particular problems heavily. So definitely they will give you a consent in order to do the liberal valuation for this afternoon paper. So nothing to worry, be happy, you will get maximum score. Have a good day.